I am Smita Patnaik from Electronics Department. So today we discuss about logic gates. So logic gates is nothing but the basic building blocks of any digital system. Here we study some basic gates. Okay, so the first basic gate is a NOT gate. A NOT gate means it is also called as a inverter, which has only one input and one output. It's a device whose output is always the complement of its input. The output assumes the logic 1 when its input is at logic 0. The output assumes the logic 0 when its input is at logic 1. The IC number of your NOT gate is 7404. Okay, see the truth table of NOT gate. If we provide input 0, the output becomes 1. If the input becomes 1, the output becomes 0. Next, we go forward to our one more basic gate. That is your AND gate. Okay, an AND gate has two or more inputs but only one output. The output assumes the logic 1 only when each one of its input is at logic 1. Okay, the output assumes the logic 0 even if one of its input is at logic 0. Its function is multiplication. Okay, the IC number of AND gate is 7408. See the truth table. A and B are two inputs. Okay, if 0 and 0 is given to the input to the AND gate, so output becomes 0. If 0 and 1, the output becomes 0. If we provide 1 and 0, the output is 0. If 1 and 1 are the two inputs to the AND gate, the output becomes 1. Okay, next here OR gate. It is one more basic gate. Okay, the OR gate has two or more inputs but only one output. The output assumes the logic 0 only when each one of its input is at logic 0. Here see the truth table. 0 0 means 0 0 1 1 1 0 1 1 1 1. Okay, the IC number of the OR gate is 7432. Its function is A plus B. Next we look forward to our universal gate. So why it is called a universal gate? Because by using these gates we can implement different gates. First we study about NAND gate. Okay, a NAND gate means not AND. That is, the AND output is noted here. The output assumes the logic 0 only when each one of its input is at logic 1. The output assumes the logic 1 even if one of its input is at logic 0. Okay, so the IC number of your NAND gate is 7400. Its function is just the opposite of your AND gate. Okay, just see the diagram of your NAND gate, which contains two inputs A and B. Okay, let's check the truth table of the NAND gate. Here two inputs A and B. If 0 and 0 is inputs, then output becomes 0. 1. If 0 and 1 is your input, the output becomes 1. If 1 and 0, the output 1. If 1 and 1, the output becomes 0. It's just the opposite of your AND gate. Okay, one more your universal gate is NOR gate. NOR means not OR. That is, the OR output is noted. The output assumes the logic 1 only when each one of its input is at logic 0. The output assumes the logic 0 even if one of its input is at logic 1. If 0 0 1 0 1 0 1 0 0 and the inputs are 1 and 1, the output becomes 0. The IC number of NOR gate is 7402. Okay, its function is A plus B complement. Next, exclusive gate. Okay, exclusive gate means it contains two or more inputs A and B. If the inputs 0 and 0, the output becomes 0. If the inputs are 1 and 1, the output becomes 0. But in rest cases 0, 1 and 1, 0, the output becomes 1. The IC number of XOR gate is 7486. Okay, students. So next we go forward to our one more exclusive gate, that is XNOR gate, which contains two inputs A and B. In case of XNOR gate, if we provide 0 and 0, the output becomes 1. If we provide 1 and 1, the output becomes 1. But in rest cases, 0, 1 and 1, 0, the output becomes 0. Just opposite of your XOR gate. The IC number of XNOR gate is 74266.